lecture on Industry 4.0. Today we'll be discussing the role of AI in Industry 4.0. So before we begin, let us learn what is AI or artificial intelligence. So it is the study of computer systems that attempts to model and apply the intelligence of human mind. It simulates the intelligent behavior in computers. It is basically the capability of a machine to imitate intelligent human behavior. Like we as humans take our own decisions, similarly, machines can be trained so as to take decisions. Before going into detail on what is AI and what are the different types of AI, let us learn the early history of AI. So it was in 1950 that English mathematician Alan Turing wrote a landmark paper titled Computing Machinery and Intelligence that asks the question, can machines think? So further work came out of a 1956 workshop at Dartmouth sponsored by John McCarthy. In the proposal for that workshop, he coined the phrase a study of artificial intelligence. So that is where the actual word called artificial intelligence came up. So let us now look into the different types of artificial intelligence. So typically there are three types of artificial intelligence. The first one is a weak artificial intelligence or weak AI. So in weak AI, machines can learn and judge for clearly defined tasks. Weak AI basically focuses on one task and cannot perform beyond its limitations. Okay. Similarly, there is another kind of AI called strong AI or strong artificial intelligence, where machines think and solve problems independently. So strong AI can understand and learn any intellectual task that a human being can do. So researchers are still striving to reach strong AI. Whatever research work we see right now, they are mostly based on this strong AI. Then the third category is the super AI or super artificial intelligence, where machines have intelligence far beyond human. So this is a case where the super AI will surpass the human intelligence and can perform any task better than a human. This is still a concept and hasn't been practically implemented yet. Similarly, if we look into the different uh, subsets of this artificial intelligence, we'll find different terms like deep learning, machine learning, artificial intelligence. So let us have a look. What is the relationship between machine learning, deep learning, and artificial intelligence? So as you can see in this figure, that the machine learning and deep learning are basically subsets of this artificial intelligence. While artificial intelligence, also called machine intelligence, can be understood by an intelligence unlike the natural intelligence showed by humans and animals, which is demonstrated by machines. It looks at ways of designing intelligent devices and systems that can address problems creatively, that are often treated as a human prerogative. Thus, AI means that a machine somehow imitates human behavior. Similarly, as you can see, machine learning is an AI subset and consists of techniques that enable computers to recognize data and supply AI applications. Different algorithms such as neural networks contribute to problem resolution in machine learning. Similarly, there is something called deep learning. So deep learning, often called deep neural learning or deep neural network, is a subset of machine learning that uses neural networks to evaluate various factors with a similar framework to a human neural system. Like we have neural system in our brain, so this imitates that kind of mechanism. It has a network that can learn from unstructured or unlabeled data without supervision. Let us now learn the relationship between machine learning and deep learning and the artificial intelligence. Machine learning and deep learning can be seen as sub-concepts of artificial intelligence basically. More precisely, the sub-concept of artificial intelligence is machine learning, and the sub-concept of this machine learning is deep learning. The major aim of machine learning is to allow the systems to learn by themselves through experience without any kind of human intervention or assistance. So basically deep learning is a sub-concept of machine learning and can be said to be a system that learns through numerous simulations and trial and error. Deep learning is basically a subpart of the broader family of machine learning, which makes use of neural networks, similar to the neurons working in our brain, to mimic human brain-like behavior, like I was just discussing. Deep learning algorithms focus on information processing patterns mechanism to possibly identify the patterns just like our brain does and classifies the information accordingly. Another fact is that deep learning works on larger sets of data when we compare it with machine learning, and the prediction mechanism is self-administered by machines. So that is how they differ from each other. Similarly, this artificial intelligence can be again categorized into different types like artificial narrow intelligence, artificial general intelligence, artificial super intelligence. Similarly, machine learning are of again different types such as supervised learning, unsupervised learning, reinforcement learning. If we look into deep learning, similarly deep learning can be categorized into 4 different fundamental architectures like supervised pre-trained networks, convolutional neural networks, recurrent neural networks, and recursive neural network. Now, just to give you an idea, let me just show you some examples of these different AI techniques. So, if we consider artificial intelligence, some of the examples of artificial intelligence are like Google's AI powered predictions, then ride sharing apps like Uber and Lyft, commercial flights where the autopilot is there, that is also an example of artificial intelligence. Similarly, some examples of machine learning are the virtual personal assistants like Siri, Alexa, Google Now, all these things. Similarly, email, spam, and malware filtering are some of the examples of use of machine learning. Similarly, if we look into deep learning, some of the examples are, let's say, sentiment-based news aggregation. Let's say you are trying to find out the sentiment of people looking at the different tweets on Twitter. Those are some of the examples. Similarly, image analysis and caption generation are some of the examples where deep learning can be used. Now that we have got an idea like what is AI and what are its different types, let us learn the need of AI in Industry 4.0. So in order to show you the need of AI in Industry 4.0, I'll be showing a simple video. So this video actually shows some of the applications of artificial intelligence in Industry 4.0. You can see how and where they can be used. So as you can see, it can be used to reduce machine failures, improve quality control, increase productivity. Then for lowering cost, if we can optimize the production process, we can obviously lower the costs. Some other applications are in customer service, maintenance, marketing, logistics. So cognitive text extraction is also one of the applications which can be used in this context. So besides all these, in manufacturing also this AI can be also used. These are some of the examples like drone enabled cognitive inspections. Then you can get some immediate insights into your production process or into your market or into your sales. All these things, all these kind of information are available. In the production process, as you can see, robots will be replacing humans. So there are many applications of AI in Industry 4.0. So AI based automation is also possible. Due to this, there will be lot of effort savings. Okay, it can be also used in next generation manufacturing. Okay, where there are very less standardized product and you have to manufacture according to the user's demand, like we have seen in the earlier video that we covered in lecture 2. Now, industry 4.0 entails networked factories deeply integrated into the supply chain, design, production and quality control. So AI driven smart systems offer practical insights. Now, to leverage its potential, holistic production processes must consider supply chain cooperation. AI, ML, and IoT are adopted for asset control, supply chain and resource management, enhancing asset tracking, supply chain visibility, and predictive maintenance. For example, let's say you have a machine and you are collecting the diagnostic data from a machine. You can use AI to predict the machine failure, and in fact you can provide maintenance before the machine actually fails. So AI aids efficient factory floor time monitoring, while ML combined with equipment effectiveness enhances production, maintenance, and workload management. These are some of the applications where AI can be used in Industry 4.0. Now, let us have a look on the technological features and traits of the artificial intelligence for Industry 4.0. So there are actually 4 different traits. First is the operations technology, second is the data technology, third is the analytics technology, and the fourth is the platform technology. So these enablers support the AI practice to make the Industry 4.0 sphere more accurate, precise, quick, optimized and secure, to make Industry 4.0 more effective and realistic. So here are some of the applications of AI in Industry 4.0. Like we were discussing in that video, it can be used for research and development, knowledge creation, fraud detection, human resources, supply chain, customer experience, predictive analytics, real-time operations management, customer services, risk management and analytics, customer insight, pricing and promotion. These are some of the major applications in industries. Similarly, if we consider the healthcare sector, it will greatly benefit from the use of artificial intelligence. Some of these examples are, firstly, it can be used for training purposes also. Then for research, also it can be used. End of life care, treatment, sometimes it can help in decision making, diagnosis, from MRI images or CT scan images. We can in fact use machine learning to find out and detect the diseases. Similarly, early detection of diseases. Sometimes what happens, the physiological signals of our body might change before a particular disease happens, such as before a stroke happens, so ECG and some other parameters might be abnormal. So we can use AI to detect such anomalies, and we can actually prevent those diseases. So AI has a lot of applications in healthcare. Similarly, it can be used in industries for HR also. That means human resource management. So in the case of human resource, it can be used for learning, curated training. We can actually understand the learning ability of a person, and accordingly we can suggest the different training modules. So skill development is another area, recruiting, okay, dynamic career sites, smart sourcing. Similarly, onboarding, engagement are some of the examples where AI can be used in human resource. And in supply chain, okay, it can be also used to understand the different issues in a supply chain, okay, and we can optimize the supply chain using AI. In fact, AI can be used to study what are the prerequisites of a bottlenecking. So once you find some factors that may lead to bottlenecking, you can in fact try to eliminate those issues. Similarly, AI can also be used in banking for fraud detection. So now one major question is, why is this AI booming? Actually, increased computing power, big data availability, improved algorithms, then industry adoption, and technological convergence has created a favorable environment for the boom of AI in the recent years. So it is high time that we use AI with the Industry 4.0 and try to improve the manufacturing process. Next is, let us have a look at what are the advantages of AI. So some of the advantages as have been listed here. One is reduction in human error. Since machines will be doing the tasks, there will be reduction in human error. Zero risks. If there is a difficult task where there is a risk to the life of a human being, so in case of that, a robot can be sent. So there are zero risks there. 24 into 7 availability. The AI doesn't have to eat, drink, and sleep. Of course, it will be down for maintenance for some time, but 24/7 availability is a big advantage. Digital assistance, new inventions, unbiased decisions are also possible. It can perform repetitive jobs easily. Daily applications. AI can be used in risky situations. It is similar to actually that is zero risk. Then faster decision making, okay, pattern identification, medical applications. These are some of the major advantages of AI. Now, since we have learned the major advantages, let us learn what are the disadvantages of using AI. The major disadvantage is substantial dependency on data. If the quality of data is poor, the AI won't learn correctly and may give you wrong results. Then high costs. Sometimes the implementation of AI can have high costs. If we are going to replace all the industrial robots with AI powered robots, it may have good amount of cost overruns. Then no creativity. What the way you train them, they will work in that way. So there will be lack of creativity. Unemployment might be an issue because once AI replaces human beings, so lot of unemployment can come up. Then makes humans lazy. That is one of the issues. Another major issue is the AI is a simple machine and has no ethics. In fact, ethics have to be implanted into the machine learning process. That is again one challenge. AI is emotionless. Okay, then there is no improvement sometimes. How the way you train them, they will work in that way. Another issue is bias can be planted in AI. So these are some of the major disadvantages that AI can have. So we were now talking about the unemployment. So let us have a look on like how this AI will affect the jobs in 2023 to 2030. So the World Economic Forum has estimated that AI will replace some 85 million jobs by 2025, which is a very large number. 65% of retail jobs could be automated by that year, which is largely due to technological advancements, rising costs and wages, tight labor markets, and reduced consumer spending. Perhaps machines are likely to replace humans in existing simple repetitive tasks due to automation and sensor technology. If so, there is a high possibility that humans will do more creative and high thinking tasks that are difficult for AI to do, and that is with little existing data. That is the major conclusion from this. Now let us have a look on the challenges in implementing AI. So some of the major challenges in implementing AI are: one is data quality, second is machine variations, then cyber security risks are another issue, then operation challenges can be an issue. One by one, let us discuss what are these barriers actually. First is this data quality. So data quality is a critical barrier in implementing Industry 4.0 due to the heavy reliance on accurate and reliable data for making informed decisions, optimizing processes, and deriving meaningful insights. In Industry 4.0, where data is at the core of operations, poor data quality can lead to errors, inefficiencies, and compromised outcomes. Similarly, the second important factor is cybersecurity. Cybersecurity is a significant barrier in implementing Industry 4.0 due to the increased connectivity and digitization of manufacturing processes. So, Industry 4.0 relies on interconnected devices, sensors, and data sharing, which opens up new avenues for cyber attacks and threats. So, cyber security is another issue that has to be handled. The next is machine variation. Machine variation actually refers to differences that exist between individual machines or equipment, even if they are meant to perform the same tasks within a manufacturing or production process. These variations can arise due to factors such as manufacturing tolerances, wear and tear, maintenance practices, and environmental conditions. While some degree of machine variation is normal, it can pose challenges when implementing Industry 4.0. Then the next challenge is the operational challenges. Operational challenges are significant barrier to implementing Industry 4.0 initiatives due to their potential to disrupt the seamless integration and adoption of advanced digital technologies. These challenges can arise from complexities of transitioning traditional manufacturing processes to the interconnected data-driven system that characterize Industry 4.0. So these are the major issues. So before we wind up, let us have a look on some of the applications of AI. For example, this is a video from Boston Dynamics, okay, which shows us some of the uses of this AI in military applications. In place of soldiers, we can use these robots basically. If you use soldiers in a war, that may result in the loss of lives, so there is always a risk there. In place of that, if we use robots, you can see they can easily replace the human soldiers. While some of the issues like ethics, emotion, all these may not be present in the robots, but we have to again think of ways to implement the same. So I'll show another video. So this is another example of use of artificial intelligence in industrial manufacturing. So this is a factory. So this is a factory of BMW, and you can see what the employee is doing is he's taking some pictures basically to train the artificial intelligence. Actually, there is a combination of these stickers that they put at the back of the vehicle. Okay, so the combination might go wrong. So that's why what they are doing is they are trying to train AI to reliably find out whether the correct stickers have been placed or correct emblems have been placed. So this is one of the examples of use of AI. Similarly, this is another example. It is in the production process, as you can see. So here they are actually manufacturing different spare parts of a car. So the camera is taking some pictures of the manufactured spare parts. So once the pictures are taken, okay, one human operator actually identifies the defects so as to train the artificial intelligence. Once the artificial intelligence learns how to identify such issues, such defects, it can in fact automatically identify such defects and reject these specific products. So as you can see here, the faulty parts are identified and are replaced. So this is how artificial intelligence can aid in the production process. So thank you for your patient listening. We'll meet in the next lecture.